Good morning, 5.6, or good evening when you see this. 5.6, differentiation of inverse trig functions. You've already gotten a sheet that has all these graphs on it, all right? And it's also on page 374 of your book. Just to talk a little bit about the domain and range, okay? I'll leave this up here for the domain and range. The domain, if you look at the graph, is always the x values, the range is always the y values. So it's important to know the domain and range of these functions. By knowing the domain and range of the functions and the way they look might get you an idea of how to solve some problems. So this is really what we're going to be doing. We're going to take these inverse trig functions and we're going to start differentiating and integrating them. So the first problem, and here's the rest because I'm probably down here. First problems I'd like to talk about are these. Arc sine, the arc, is usually answers what angle? Whose angle or what angle has the sine of negative 1/2? So if I think about it, even if I make a right triangle, a 30, 60, 90 right triangle, there it is, and I put the ratios. For 1/2, it looks like 30, opposite over hypotenuse. So negative 1/2 would be negative 30, all right? Or what we would say is negative pi over 6. Now, on the graph, the sine graph, it's negative in both those points. You can call that negative pi over 6. You can call that 11 pi over 6. You can call this 7 pi over 6, okay? Has many different ways to call it, but that's where the sine is negative 1/2. I saw where it's 1/2, and I just took that reference angle. Where is the angle whose cosine is 0? If you think about the unit circle, the cosine 0 up and bottom. So this would be pi over 2 and 3 pi over 2. Arctangent. Let's go back to this triangle here, okay? This is 1 square root of 3, 2. This is 30, 60, 90. And now I'll say, okay, tangent is opposite over adjacent. If I use 60, it'd be opposite over adjacent, so 60 degrees is the one I'm looking for. And that would be pi over 3. Or 4 pi over 3 if you're in the third quadrant. Any questions? So basically looking at triangles or your tables or something like that, remember arc means whose angle. Next, some properties of the arc. If I take the sine and the arc sine, they undo each other, and you get x. Likewise, if I take the arc sine of the sine, they undo each other. So I have a problem for us to solve. Hold on, let me leave here it is. Here it is. All right, I would like you to solve the arc tan of 2x minus 3 equals pi over 4. And what I will do is, looking at this and using the property before it, I will tan both sides. So if I tan that side and I tan this side, these two will go out and I'll be left with 2x minus 3. And on the right side, tangent of pi over 4 is 1. So now this becomes a nice algebra problem, and the answer turns out that x equals, I believe, 2. Yeah. Any questions? Nice. Here we go. We have arc sine x equals y now. We want to find cosine of y. So I'm going to do my property like I did before. I'm going to sine both sides. So now I get x equals, because these guys will cancel, and it'll be x equals sine of y. Well, let's make a triangle. When we make a triangle, if this is y, opposite over, remember sine is opposite over hypotenuse. So it would be opposite over hypotenuse. Hypotenuse would be 1, that would be x, because this is x over 1. Now I can find the cosine of y. The cosine of y would be opposite over adjacent. Opposite over adjacent. And that would be, what's the adjacent side? Well, I'm going to use Pythagorean theorem to find it. I have x1, so this is going to be, I guess, 1 minus x squared quantity square root, right? A squared equals B squared plus C squared. Yes, that's good. So now the answer turns out to be opposite. This is tangent, so let's get that out. This is cosine is, sorry about that, adjacent over hypotenuse. So adjacent is that, hypotenuse is that. Voila. That's my answer. To cosine of y. All right. That's stuff that is pre-calculus. All right. Here is where the calc comes into play. Derivatives. I actually gave you a sheet with all these derivatives on it. And if you look closely, arc sine and arc cosine, the only difference is a negative. Arc tan and arc cotan, the only difference is a negative. And then these two are just a negative is between them. So really, if you know three of them and you know which one's negative, you'll be okay. So let's do some problems involving them. They're a little crazy. It looks a little crazy here, but we can do it. Arc sine 2x. So I go up top and I say arc sine is u prime over that. So it's going to be u prime, which is 2, over this, 1 minus 2x quantity squared. I'll simplify that and get 2 over the square root of 1 minus 4x squared. Done. Just using that derivative. Let's do the next one. The next one says arc tan. So let's see if we can get arc tan over here. Arc tan is u prime over 1 plus u squared. U prime over 1 plus u squared. So it's 3x squared squared. And I'll get as an answer 6x over 1 plus 9x to the 4th. Okay? Next is the arc sine. Arc sine of that. So I go to arc sine, I had it up here. It is the derivative of the u prime. Okay? So that's going to be 1/2 x to the negative 1/2 over square root of 1 minus the square root of x squared. So I'm going to square this and join with the band. So I'm going to get 1 over 2, I don't want it this long because there's one more step. 1 over 2 square root of x times the square root of 1 minus x. Now I can distribute that in there because they're both radicals. So I'll get 1 over 2 square root of x minus x squared. Okay? All this was kind of, all this stuff was kind of factoring and making sure it works. This one, arc secant of e to the dx. So this is going to be derivative up top, 2e to the 2x over, now this is the one over here, if I scroll up, arc secant is this one, where it's u and then the square root of u squared minus 1. So it's u, I know it's absolute value, but square root of u squared, which is this, squared minus 1. Immediately I can cancel those. Nice. Let's talk about the squared in here. When you square a square, like 5 cubed squared, you multiply them to get 5 to the 6th. So that's what I'm going to do. I'll multiply these. So I'm going to get square root e to the 4x minus 1. And that's it. You guys have any questions? You have to know that. You have to know these derivatives right up here. Important. Let me give you some practice, please. Homework will be page 379. We're going 5, 8, 9, 19, 27, 38, and 60. You might be saying, well, you're kind of giving us a lot. You know, you watch the video and then you're giving us a lot. These first 3 problems deal with those triangle things before, and these are easy derivatives. I have given you no integral problems because we'll do those in class. All right? We'll do the integrals in class. Those are some of the derivatives. And thanks for watching.